fixed deposit, etc. If the same person may go to a blood bank and ask to become a potential blood donor, the blood bank starts specifying me in terms of completely different set of parameters. Whether I have thalassemia, what is my blood glucose level, what is my age, blood pressure, and so on. Similarly, the deep neural networks is an end-to-end system which senses the context of classification from an objective function to be optimized at the output, and based on that, okay, I have to demarcate between cars versus non-cars. So I should look for higher level features like engine, pipe, steering, wheel, etc. Oh, now my context is to classify between birds versus non-birds, so I should look for feather, beak, tail, wing, etc. Are you somewhat getting it? So this context-sensitive optimal representation learning is the biggest selling point, based on which deep neural networks started to, reign over the world of computer applications since 2012, I should say, because that time a very big breakthrough happened in ImageNet classification. And these developments of this layer-wise architecture started from 1982 with the publication of one paper in the PNAS journal by John J. Hopfield, and follow-up works in PNAS and Nature by Geoff Hinton and his team. And as a result, at that time, artificial intelligence was not at all a very elegant term in the scholastic communities. So they used to classify everything under physics. As a result of that, this year, the duo won the Nobel Prize in Physics, but because of these inventions. Okay? This is Hopfield and this is Hinton. Now, the modern deep inference models have two aspects. One are called the predictive or discriminative models, like the convolutional neural network. These models first represent complex pieces of data. By complex piece of data, I mean nowadays, image is a complex piece of data. All of us has megapixel cameras, phones, and very high resolution images. But now even every Facebook profile is a complicated piece of data containing image, text, video, political opinion, whatnot. Anyway, so first, these complicated pieces of data are represented as these geometric points in some higher dimensional feature space. And such cloud of points sticking together should represent one good class. Like these points, yellow points are for cat, these blue points are for dogs. And the predictive or discriminative model is very happy to learn a decision boundary, which in very simple case would even be a straight line to demarcate between the two classes. On the other hand, there are generative deep inference models which do not care about, okay, these are the classes, those are the classes, I need to find a fence between them. Their more important point of emphasis is the spatial multivariate probability distribution from which these points have been sampled. As I say, to a statistician or probabilist, everything is basically sampling from an underlying random process. So there has to be some underlying rules of probability which could ideally define a probability distribution from which these data items must have been sampled. So by looking at these samples, can we even approximately estimate those probability distributions? Deep generative models answer the question in affirmative, and therefore, if they can estimate that distribution, in the next phase, they can sample from that distribution. And sampling from the distribution means they can create extremely realistic but actually artificial images, text, video, whatnot, voice, everything. That is where generative models come. Now, generative AI has become an umbrella term for learning algorithms that can produce new content based on a prompt. What is prompting? You must have heard of prompting, right? Not in context to drama. Prompting means giving specific instructions to a generative AI model in your own speakable language. This was the dream of Geoff Hinton and his community for a long time. How to interact with a computer, not in C, C++, Java, etc., but in simple English, simple Bengali, simple even Hindi. Now, the Bharat GPT is coming to account for all the regional languages. So prompt is that. And the more generative AI model, the pinnacle of which is LLM or VLM nowadays, they should give you very realistic but actually artificial text, code, image, audio, etc. This is now the role of generative AI, where we are going. And this is one of the first generation Gen AI model, which is very easy to explain, called GAN, or Generative Adversarial Networks. This is our personal favorite because I'm trying to develop a statistical backbone for GANs. And theory always lags behind the developments here. So GAN already has taken a backseat. Let me tell you, it was originated, the first paper came in 2014, NIPS conference. Now people are saying, oh, it's a first generation model. That means already we are in third generation of stable diffusion. But what does it do? Let's try to understand this. Very simple architecture. GAN has two neural networks inside. Every neural network could be seen as a simple function y equal to f of x. X is your input and y is your output. Nowadays, neural networks are like this. Okay, X could be an image of, let's say, 1 megapixel size. That means 1,000 pixels by 1,000 pixels. 1 million raw pixels are there inside X. So that image is going inside the neural network, which is modeled as a function. And its outcome Y are 10 words, which sitting together describes what is happening inside the image. Okay, a black dog is running in a green park. So this description is called captioning. Image captioning has become so easy, you can do it with your smartphones now. But this is basically done with a neural network architecture. Okay. So this generator is a neural network whose input X are random noise vectors, which could be 50 or 100 dimensional, and output is a matrix in the form of an image. And there is another neural network or distributor whose input X is an image and output Y is a continuous score between 0 and 1. This neural network or discriminator is like the teacher. It has access to external repository of real-world images. So it knows what is the good standard of real-world images that this generative architecture should actually synthesize based on this feedback from the discriminator. So generator is creating images. Initially, they are very poor, very bad quality images because the generator weights and biases, the internal parameters of the function of the generator are untrained. So these images will get very poor score from the discriminator, and it's like the teacher grading the answer script of a student giving very poor score, and the student is very motivated. The student burns his midnight oil to curate better answers. So the generator similarly, based on the feedback from the discriminator, corrects its weights and biases, tunes them until it creates much better images on the output. And the discriminator then also upgrades itself by accessing more real-world images from the training set and learns the subtle differences between these generated artificial images and the real images. This improvement, competitive improvement of these two neural networks go hand in hand, go in an intertwined way. So we say these two neural networks engage themselves into a two-player zero-sum game and try to reach the Nash equilibrium in game theoretical contexts. There are nice theories for it. And this way, when the training converges, the generator actually does something like this. So here you can see first 50 inputs of GAN's training, the generator output, when GAN is trying to generate human handwritten digits. So initially it's all the noisy pixels, and then the generator learns how to arrange these black pixels suitably to mimic the human handwritten digits. However, it was not meant to do so simple things. In 2014, when the GAN's paper was first published, we didn't have the comfort of using RTX GPU series or L40 or A100, etc. Then as time passed on, in 2018, the Big GAN project came from Google DeepMind. You can see the gray hairs, the wrinkles, every detail of the face of this lady. The lady doesn't exist. This image was never shot with a camera. It was a synthesized image by GAN. Okay, so any generative model is like that, and you show it example images of a specific type, maybe human head and shoulder images, and it will then create its own human head and shoulder image of somebody who is ghost, who doesn't exist. You get my point? Soon thereafter, so this was one development, and several such developments started to happen almost parallelly in the conditional GAN or CGAN, which tries to constrain the generation space of the discriminator, of the generator, sorry, by using specific ground truth levels. Okay, GAN has to generate human face images. Can I have all images to have a French cut and a pair of glasses and male? Can I constrain the generation? Can I condition the generation? Based on that, several types of conditioning networks were proposed, which could convert the input winter landscape into summer landscape and so on. And there is a strong statistical theory of how this conditioning constrains the statistical manifold of the estimated distribution, but I'm not going to discuss those mathematics here because that can bore you. So you see, then people thought, okay, why only full images? Why not more pixels inside an image? Why I have a low resolution image. And low resolution image means pixel per inch is very low. For example, here you can see 135 pixels only in resolution. Which movie is this? Interstellar, right? So now people thought, okay, I have this sort of a frame. Why not add more and more and more pixels to make it look more detailed? These pixels were not there during the production of the frame or may have been lost because of the compression of the frame. Where from they again came, they were fabricated, generated by a super resolution GAN architecture. And this process is called super resolution. Now you take a very poor quality picture from WhatsApp. Your friend has sent it not as a document, but as a simple WhatsApp image. And then you can super resolve it by making it look like more detailed as if shot with a DSLR by using SR-GAN backed architectures like this. And in 2017, ICCV is one of the very great and biggest event in the world of computer vision. There came the two parallel GAN architectures for unpaired image-to-image translation. So in 2017, the challenge was, okay, I have one image, the content of the image should remain unchanged, but the style of another image should be imposed on that image without explicit photography, without the need of having a big studio for doing all these things. These were there in computer vision, computer graphics for a long time, but it would require lots and lots of adjustments and big process pipeline. CycleGAN did that in a very simple way by using two GANs in parallel, one transferring the source image to the target image and the other one transferring back to match how much the content remains unaltered using two different loss functions. And as a result, you see the style of the zebra, that means these black and white stripes, have now been imposed on this horse. And you could add the gaming environment of PUBG onto Fortnite and create a new game. Now it's very easy to, create games and, deceive the copyright by doing all this stuff. Not a good practice. And now, soon after 2017, 2018 Interspeech. Interspeech is the biggest conference in the world of speech analytics and speech processing. Interspeech was flooded with the same technology used for voice-to-voice conversion. Nowadays, the entire dubbing industry does that. So you need not fly Nagarjuna or Chiranjeevi from southern states of India to Bombay to have them dub something. They can be there. You can easily imitate their vocal style and have make up for the gaps in the dialogues when the movie is actually being post-processed. I can have this entire lecture delivered in the voice of Mr. Bachchan. So content is mine, voice is from Amitabh Bachchan. It's very easy nowadays, although there are legal issues. Of course, I cannot do that. And this is one of our works, which used a more intricate Wallenstein loss function. In fact, optimal transport, I don't know how many of you are familiar with. It's a wonderful problem coming from probability theory, mapping one distribution towards another distribution. And Wallenstein loss is based on this optimal transport problem, which is 300 years old. and resurrected in the domain of machine learning just in 2017. We used this optimal transport-based loss for a conditional image-to-image translation of more abstract expression. So more abstract means, you see, this is not so explicit like the stripes on the zebra. This is an abstract expression in the face of this male actor, which has now been translated into female actor faces. Or the cold fear of this cat has now been translated into all these dogs' faces. If you look at the eyebrow and other regions, you will see them to be similar gaps or similar, waves on the eyebrow and so on. This is a video which perhaps will not play because of version mismatch. Yes, it's not playing. So this video actually shows the continuous transformation, how Dave Patel's facial features when composed on some lady actresses, how they look like and so on. And this was done on GEN. GEN stands for Generative Equivariant Networks, which uses capsule nets instead of normal neural networks. Then this is one of our interesting work in the same ICCD conference, which uses a three-layer GAN for class imbalanced situations in image classification. Class imbalance means you scan the chest X-ray image of 100 patients, of which there are heavy smokers, and only 4 out of them are showing small white patches, microcalcification spots all over, or nodules all over their lungs. And these are indicative of that these people will develop lung cancer. Okay. Your machine learning system is heavily biased on the big class, majority class of benign people. We are fortunate, the benign class is so big. So it misclassifies all the 4. Okay. So its accuracy becomes 96%. It's only 4 misclassified. Is it good? No, it is dangerous. It is actually issuing no warning sign to those 4 people who are very much vulnerable. Am I clear? This is called class imbalance situation. Any rare event detection is a class imbalance situation. Fraud detection, financial fraud detection to rare disease detection, everywhere we face it. So this particular architecture changes GAN into a 3-layer GAN. It uses a convex generator to generate extra images inside the minority class, which is this red class, and then a discriminator to sense the statistical distribution of this minority class and spread these generated points like this, so that now the 2 classes appear to be almost equally populated or balanced to the classifier, and the classifier puts its decision boundary like that. So GAN, I'm not going to tell you much big details because everything, including the source codes and other things, are available here. It's a 3-layer architecture specifically for solving the class imbalance problem. And now, the most important generative models from imaging perspective is slightly important, is the diffusion models. Diffusion models, what they do is, and this diffusion model entire setup started to develop since 2018 actually. A very young boy who last year gave a talk in my winter school on deep learning at Icaa also. His name is Yang Song. He graduated from Stanford University and joined as a faculty now in Caltech. His PhD work was this diffusion model actually. What is this? What they are basically doing is they are adding Gaussian isotropic noise into different real-world example images in steps until the image is completely noisy. Then they are removing that noise stepwise by using a neural architecture, maybe a unit or maybe a denoising autoencoder in its simplest form. And this forward and backward diffusion steps go on for lots of real-world images. Once these steps are completed, then what happens? Then they take any completely noisy image like this one, and their neural architectures are already trained to stepwise denoising. So they denoise it through those neural architectures to get this sort of. And once this image is denoised, they get a completely new image of something which is not a carbon copy of the training set, which is a new image, but belongs to, looks very stunningly realistic, not a carbon copy, and that's what is expected from a generative model. Diffusion models are based on this philosophy that the sculpture is actually inside the rock. You only need to chisel away the superfluous extra rock material. And diffusion models form the backbone of DALL-E 3 and many other image generators that from text prompt that we see today. So we were moved into traditional ML. You have to classify between fraudulent and benign, fraudulent and genuine transactions, bank transactions. You have to classify between malignant and benign images. Every time you train a neural network or a live Bayesian classifier or a decision tree or a random forest from scratch, have it perform your task and then scrap it. This was traditional task-specific ML. Then since 1990s, people started to think, why waste our ML system that was trained on a specific task? Why not, like human beings, we are in our mid-career. You are starting your career, many of you, I can see young faces. So as you grow older and you solve different problems under different industries or different academia or different circumstances, what you gather is an experience of solving those type of problems. And that experience is actually very much valuable. They help you to get a better job, place yourself in a better way, and so on. Similarly, can the machine learning systems accumulate the experience of solving problems? So they are trained on many different data sets. They solve problems of specific to those data sets. They gather experience, store it, and use that experience to solve another problem. So a machine learning system which is trained to demarcate between small cars, motorbikes, and big trucks, the knowledge that it gathers from there, can it be further used to demarcate between big elephants, small deers, and rabbits? The answer is yes, with very little change in their architecture. This gathering knowledge on one part of task, storing it, and reusing it with little change for another context is called transfer learning. Okay. Now we are moving towards something very big, starting from 2022, and with the release of ChatGPT, actually people became alerted of these huge versatile systems called foundation models. Foundation models are not foundational models. Foundation models are something else. They are huge, large-scale machine learning systems trained on massive amount of external data, and then they are inherently multitasking. They can do lots of tasks and give you a versatile set of outputs. Like a human being, we are all multitasking, right? Machine learning is trying to mimic human brain. Human people are obviously multitasking. In the whole day, how many jobs do you perform? Do you only listen to boring lectures like this? No. You can cook, you can drive, you can raise your children, you can chat with your friends, you can post on Facebook, all these jobs. Simple, single person is doing. Similarly, foundation models can perform such versatile amount of jobs. And that is the reality. Now we are moving towards this. And one example of foundation model in vision is this SAM. SAM is now reigning over all segmentation methods that have been published over the last 30, 40 years. This is also another ICCV paper, ICCV 2023 paper. So you give this image as input and you want to segregate one cat or uniquely identify one cat. You can do that by specifying a few points or a boundary box or approximately where the cat is located, or even with a text prompt, cat with black ears. So the model will identify this cat which has black ears. This is called a segmentation specific foundation model in computer vision. So deep generative models were mainly used to generate synthetic data which can be used in different applications. And when we just thought the AI is going to be saturated, okay, the developments will become sluggish now. Only at that time, the entire world was taken with storms with the advent of large language models. And they are based on this famous quote by the legendary computational linguist, John Fort. Large language models, what are large language models? These are huge machine learning systems, foundation models, that can interact with human users by pretending that they understand the syntax and semantics of a human speakable language. So what did I say? Pretending that. They have to pretend. Semantics, understanding language semantics. Syntax is easy. Semantics is not easy. Not possible, actually. Chomsky was extremely against that the machines try to understand semantics of a language. When I say I have sensory organs and I understand, or any of you understand language very organically, when I say red mutton curry, so in my inner eyes, the dish picture flashes, my salivary glands gets excited and so on. But computers, for them, red, how to understand this word red? They have a vocabulary. They will see with which other words red is being composed. We say algebraic compositionality. Red is sitting with many other words. Red book, red idea, red fire truck, red riding hood, red mutton curry. And then statistics. How many times red is most frequently sitting with which other words? So based on this compositionality and frequency, somehow the meaning of red will be quantitatively formed in the machine memory of a large language model. This is how they perceive. So that's what large language models do. Language model is fine. It has been researched upon since 1960s. NLP was based on them. Language uses a finite number of symbols or tokens. We assume a finite token set of size K. Tokens may be letters, words, sounds, levels, etc. And these parts of the speech or parts of the text are actually encoded in a floating point vector. And you can treat the language model as a stochastic process where you are putting this y1, y2, y3, and then you need to know after k minus 1 such tokens have been outputted, what is the kth token. So the probability of what is the probability of the p of yk given yk minus 1, k minus 2 up to y1. Models are typically autoregressive, predicting the next word from previous. This was language model, but large language models are those which come up with huge number of internal parameters. Typically, for example, GPT-4 has 100 trillion parameters, which needs to be optimized and which can then be trained on a huge volume of internet-based text in almost an unsupervised way. And then they can be fine-tuned for your specific purpose. These are some of the large language models which were released since 2022 to compete against OpenAI. Google, Meta, everyone came to the market and they released this, of which this is a typical fine-tuned large language model called MID-PaLM2, which is Pathways Language Model 2 fine-tuned version for medical image. If you upload this sort of a medical image, maybe a chest X-ray image, it can write down a summary of what are the anomalies inside the image, findings and impressions, etc., like a pathological expert. So, with this large language model, we are actually moving from AI to AGI. Let me outline this and then we go to the ethical issues and then we will wrap up. How much time do I have? How many? 15 minutes? Sure. It's okay? Because I will take some time to explain this interesting concept. So traditional programming was like this. You are all master of that. Smart human being like you, the programmer, is sitting there specifying certain rules. Okay, if the animal has 4 legs, 2 ears, likes to take urine, cat leave, then it's okay. And the computer, just like a clerical person, following these sequential sets of instructions encapsulated in a program, matches against these clause and then infers whether it's a cat or dog. Then there came the wave of neural networks. Pinnacle was in 2012. What was this wave about? It was about showing, instead of specifying any rules by a smart human being, showing the computer thousands of cats images, thousands of dog images, thousands of rat images, and then asking the computer, showing it a new image, what is this animal? Cat, rat, dog, what is it? And the computer learns the implicit differences and can infer by using neural net. Then there came the generative language models. And what is that? Now let me tell you, this is more like you are a very motivated teacher. You don't like to spoon feed your students. I mean, this is for teachers. So you don't tell them 9 questions out of which 7 will come in the semester. And a student goes to you, asks how to distinguish between cats and dogs. And you then take the student to the library, put him in front of 3 almirah full of books, and ask him, well, these books contain every detail about the animal kingdom, their taxonomy, their evolution, everything. You read all of them, then you come back to me, I will ask you questions. Student has 2 options, either to run away and never come back, or to or to burn his midnight oil, read all those books. Student is also equally motivated, so the student reads all those books, comes back to you, and then you ask him questions, not only about cats and dogs, but maybe about millions of other animals, other animal species. And the student answers all of them. Even it could so happen, you show it the picture of a huge big animal not included in any of those books, but the student can still map, okay, this animal has tails, a big tail, lays eggs, must be some very big reptile. You have shown it a dinosaur, and the student can still answer it. In machine learning, we call it zero-shot learning. Something out of syllabus, but with your existing knowledge, you are extrapolating, stretching that knowledge to infer something about that. You get me? This is what exactly large language models do. These large language models are initially trained in an unsupervised manner without any teacher on huge internet-based data repositories. They gather millions of concepts, and then they could be fine-tuned. So pre-training is unsupervised on huge internet-based models, and then they could be fine-tuned. Fine-tuned for specific purposes and with very little amount of data. Another example, okay. Yeah, something that happened. Okay, another example is training a dog. So you take a dog puppy and then you train it basic postures like sit, come, down, stay, etc. But if you wish, I don't know why this is fine, but here the graphics is somewhat problematic. Really strange. Can I just start it once again because it's gone? The graphics is completely messed up. Where is this copy? Completely messed up. I don't know how. Maybe because of your version mismatch. Just take my bag and let it show from my computer. That would be easier. Unless these graphics are shown, you cannot really understand it. It is not being shared. Is it being shared? No, anything, right? It's not being shared. Otherwise, we could have. Yes. So it's like training a dog. And then if you wish to have special service from the dog, like you want it to become a police dog, guide dog, or hunting dog, then you need to give it more training, but that will take much less time if it has gripped those basic postures. Similarly, LLMs are first trained on huge internet-based text to solve common NLP tasks like text classification, question answering, document summarization, text generation. And then they are actually fine-tuned for various purposes with very little training data. In 2023 in India, 150 startups came up with very good rolling out rate, which were actually modulating GPT 3.5, that means Chat GPT, the LLM behind Chat GPT, for doing several things, like generating invoice for a big restaurant chain, or maybe writing the CV for your exam. Then Canva took up a particular license agreement with OpenAI, and then Canva can now almost replace PowerPoints. Okay. Similarly, Overleaf grabbed their own, grammatical correction software interfaced with ChatGPT, GPT 4.0. And have you nowadays noted that Overleaf gives lots of suggestions? You need to purchase that service. That is also backed by it. So this way, all these are fine-tuning of the GPT for your specific, or like LLM for your specific purpose. And the heart of LLM, at the heart, there is this neural architecture, which is called transformer. This transformer is an encoder-decoder architecture. There is a neural network which is converting these input text sequences from many digital text into floating point vectors in some strange latent space. And this transformation, while doing this transformation, every word, how it is associated with other words so far inputted, that thing has been quantitatively stored in the form of a matrix that is called attention score matrix. This self-attention mechanism incorporated with the encoder made it possible to have these nice encoded vectors in a latent space where, at least in the domain of text, similar or same words should form clusters. We are trying to find out the statistical properties of this mysterious latent space. The entire world is trying to grasp it, but it's very mysterious. Mysterious in the sense, okay, ma, amma, mother, tai, all these words that mean a motherly figure should be points in this latent space in a very close neighborhood. Ishwar, Allah, God, all these words should come to a very close proximity. Otherwise, neural machine translation is not possible using this architecture. And the decoder is actually sampling from this latent space. Decoder starts generating output text in an aggressive manner. Then it has a huge vocabulary based on this encoded vector sampled from the latent space, and based on what it has already written, it assigns a probability, softmax probability to all other words, and then gets them outputted one after another to form the output text line. This mechanism is also very complicated, but this is a very, very much meta view of the thing. And machine learning people are very good at giving names. This whole story started in the publication of this paper. This billion-dollar LLM industry starts rolling with this. First author is an Indian. He was almost in his 25, 26 years of age when he wrote this, Ashish Vaswani. And the name of the paper is Attention is All You Need. So this paper first showed the attention mechanism. In a meta-level description, what is it? When as adult human beings, we read a line of text, we do not actually go through all the words. A and B, preposition, conjunction, interjection, these are automatically filtered. Our brain picks up 2-3 major keywords, finds their association with each other, and the entire sentence, the meaning of the entire sentence is formed in our head. The people with higher cognitive tendency can have higher reading speed because they can pick up these words very quickly, and in their brain, the association is also becomes. Association is mind even quicker. You know the story of Swami Vivekananda, right? He used to read the big books in very, very fast, actually. Within 1 hour, big 300-page book is read. How is it possible? Because of this high attention mechanism. Okay, he is watching a French show. Watching has a higher attention, which is a nickname, let's say, for correlation with show. On the other hand, watching should have very low attention towards the word French because it's watching, it's not listening, isn't it? So language has no role to play. So before this attention mechanism proposed by Vaswani et al., there were a plethora of mechanisms in recurrent neural networks, LSTM, gated recurrent unit, gradient clipping, backpropagation through time, huge mechanisms to handle large sequences of text. This one mechanism, this one paper came and it rooted everything out. And that's why I chose to use this name. The attention is like this casual shooter from Turkey. Do you recognize this man in 2024? And these are the usual mechanisms to handle text. Well, ChatGPT is not an LLM. It is an interface between GPT 3.5 or now GPT 4, 4.0, etc. These are LLMs. GPTs are basically generative pre-trained transformer. So they are trained on huge language models, I mean, huge internet-based text repositories, and then they have only the decoder inside them. Their encoder part is not, they have this latent space, but their encoder part is very explicit, not out for user intervention. So the pre-training is like this, and then in the fine-tuning part, GPT uses a reward penalty model backed up by reinforcement learning, where all over the world they have users. The users provide feedback on the generated content, and based on the feedback, they go on continually defining their, output text strings. ChatGPT is basically a user interface. This is the chatbot. Chatbot and LLM are not the same thing. Now we are going towards vision language models, which not only handle text, but which can handle images as well. And vision language models are inherently foundation model. They can do variety of jobs. For example, you give this image as input and then you ask, is one cat behind the other? And it clearly says, yes, one cat is behind the other in the image. The cat in the back is facing the camera, while the cat in the front is facing away from the camera. It's a cute description of this image. Then zero-shot segmentation means you are showing no example. Segment the striped cat. Both the cats are striped, so it segments out both the cats. Same model, you give different input instructions. We call different text prompts. It will do different jobs for you. And GPT-4 is one of the most well-used multimodal vision language model. If you input this picture and say, okay, sometimes I just look at pictures of the art from space and I marvel at how beautiful it all is. GPT-4 says this means a joke that combines two unrelated things, pictures of the art from space and chicken nuggets. So already by analyzing this picture, GPT-4 understands that it's a set of chicken nuggets vaguely resembling world map. Learning technology, you can ask it to generate this sort of a diagram of human heart without leveling, and it will do that. So similarly, prompt engineering is the most lucrative job in USA over the fiscal year of 2023 and both 24. Prompt engineering refers to crafting most efficiently the instructions which has context, which has example, so that the GPT or any LLM behaves like you want it to behave. One simplest, so these are some of the prompts, like instead of just saying summarize this article, effective prompting means giving clear instruction, provide a concise summary of the main points in this news article about climate change. Climate change sets its context, concise summary, main points, these words set how it should do the job. Without clear instruction, human beings can also not do a perfect job. Prompting is all about setting this clear instruction. If you want the GPT to do any logical reasoning or solve some arithmetic problem from famous Casey Knott's book, you should amend the question by let's think step by step. This is the simplest prompting technique, which was very popular, published in this paper in 2022 Icaa, I think, which actually has the GPT to break down the problem into simple logical steps and solve it. And they can be very well used in scientific exploration. Excellent coding as I will now skip many of these rows to wrap it around. Let me tell you one quick piece of wisdom from my editorial experience. If you write a paragraph of text or two paragraphs in very poor English, if you want to publish it, give these English texts to ChatGPT, ask beautify it or polish the English, then you do not need to actually declare it. Even Grammarly does that. Grammarly, have you heard of Grammarly? Overleaf, Grammarly, all these are backed up by LLMs. You need not declare that. But if you use a prompt, if you ask ChatGPT, I want to write an algorithm about smooth analysis of oblivious sorting algorithms, and write down the related work part for me covering the works from 1990 to 2024. And ChatGPT writes it at your own, including many references, some of which may be false. I'm coming to that. You very carefully check whether the text is actually generated by it or some lines are plagiarized. You need to declare that whole thing in your paper. Okay, this portion of the is written by ChatGPT. If you write it, ChatGPT polishing it, no need to declare. Otherwise, you need to declare. That is the clear policy of Elsevier, IEEE, Stranger, ACA, everywhere. So I will skip all these things. And this is one of our work where a medical report is generated for Alzheimer's detection. By this medical report is being generated by a fine-tuned version of Llama 3, which is an open source 8 billion model. We say it's very small. 8 billion model is nothing. 8 billion parameter is nothing. It's a very small model actually. And then this is one of our recent work just accepted in IEEE 2025 as a student abstract, where we are using the BLEEP language pre-training model to simplify medical prescriptions. This is a healthcare related thing. So you see, the actual medical prescription says both lungs are clear and expanded, heart and medium normal. Both of you, and when we pass it through our simplifier, our improved readability medical reports, then that says both of your lungs look clear and are expanded to their full size. Your heart and space around it appears normal. Because this word, mediastinum, may not be very familiar to our common brain. So we are planning to incorporate this in the telemedicine networks for easy access of common people. So I will speak all of this. Now, are we particularly on the right track? First, very important problem is hallucination. Large language models, start trying to wrap up in 5 minutes. Large language models are very much open to hallucination. They can misunderstand instruction. They can fabricate things up. So when you have it write down references for you, please take all the references. Some references are ghost. They were never published. Okay. Why a large language model must hallucinate? Just this year's talk to 2024, Kalai and Zenfala published a statistical model of LLMs and showed that they are bound to hallucinate. Pessimistic result, but there are active research going on to reduce the hallucination through improved prompting technique. Like you ask to translate the following English question into Spanish, what is the capital of France? And it says capital of France is Paris. Do you understand? It misunderstood the question. Okay. Young Lekun, one of the 3 proponents of deep learning, said 94.7% hate speech are taken down automatically by AI. But what is the ground reality? We have unfathomable training data in the internet, but science doesn't guarantee diversity. So LLMs all over the world are trained on internet-based text repositories. Who are the people putting text in internet? People from US, Canada, Europe, Korea, not North Korea, South Korea. So people of advantageous background. How many people from Tanganyika, Ghana, Lebanon, Gaza, or other countries, or other poor countries, downtrodden countries, how many people from those places have the luxury of uploading articles in Wikipedia? For them, 2 hours of electricity per day is a very big luxury. You get my point? So as a result, what is happening is that a limited set of subpopulation are gradually adding more and more text. And their thoughts are becoming our worldviews. Because we are feeding on the internet-based text. In our country, the law enforcement is going to be backed up by LLM. That LLM uses this training data from a limited set of subpopulations of all over the world. As a result, huge bias coming because gatekeeping is always done by those who are in power. History is basically the fiction written by people who won the war. People who were defeated, no one remembers them. Similarly, bias means giving disproportionate advantage to certain groups, come from there. If you have an LLM, if you ask it to write down, even anyone can try. Ask GPT 3.5 to write a paragraph on your family. It will inevitably write, my mom is a homemaker, my father is a doctor or engineer or professor. It will never write, my mom is a doctor, my father cooks at home. If you ask him to do downstream job, he loves travel alone. What is the emotion captured in this sentence? It will say joy. She loves travel alone, it will say fear. So the bias comes from society to internet-based data repositories, they are from LLM. We are trying to develop several techniques to measure the bias, to measure the fairness and filter them out. I will just show one last example of bias. In any image generation software, text prompt to image generation, like image, this is the example from DALL-E 3, which comes with ChatGPT. I asked it to generate 3 friends enjoying coffee at Starbucks. This prompt. It generated this. Nice. Starbucks is visible, 3 friends. Who are these friends? They are either European or American or Canadian. They are white people. You get my point? Now I give this prompt, 3 Indian friends enjoying coffee at Starbucks without giving reinforcement learning based feedback. And then it generates this. This is fine, but do we really see people in Lungi and this extremely rural attire in Starbucks? Probably no. So we get lots and lots of feedback, human feedback. India is not like this, you should not do this. Same thing. Give me the picture of a nice house. It will create house with swimming pool and glass doors, glass roofs of a European landscape. Generate the nice picture of an Indian house. It will generate a 2-story mud house in front of which there is a tulsi mancho, there is a cartwheel, there is a cow even. Once it created a cow's picture. So Indian house means that. Thereafter, we gave it many feedback and then it came with this sort of a picture. Still not good. It seems like they're going to attend some marriage reception and before that they're having coffee. It will never create Indians in casual Western outfits and having coffee. This is the problem. Similarly, so Google image search for CEO shows Barbie as the only female CEO after 11 rows of male CEOs, which cover almost all the leading CEOs of the world. Then only 1 female CEO comes, which is a Barbie doll. Can you imagine how much biased this is? Because its training data is biased. It can never think, okay, females can also be CEOs. The doctor, if you go through this conversation, the doctor yelled at the nurse because she was late. Who was late? According to the sentence, nurse was late. That's the answer from ChatGPT. The nurse yelled at the doctor because she was late. Who was late? In this sentence, it is still the nurse who was late. So it never admits that doctor can be female and doctor can be late. It says doctor must be male and cannot be late. It generates extremely toxic content about all the minority communities, including the sexual minority community. It says the gay person was known as insane and incurable. Non-binary person was a special case, a freakish one-off. If you let it generate things about people with non-binary sexual identity, it will generate toxic content because its data is like that. And that is exactly why a copy and paste technology should not work for these developments that happened in another country. End of the hour, responsible AI. What is responsible AI? First thing is fairness. You must balance your training set, augment it, or you must balance your algorithm to give equal weightage to all demographics, especially in medical AI. This skin cancer identification. Skin tone is a very important thing. If because of skin tone, the lesion and the prediction of skin cancer can change a lot. So fairness must be ensured. Interpretability, the AI system should be transparent, although transparency has a very big trade-off against accuracy. Most transparent AI systems are decision trees, then random forest, but their accuracy is way worse than the accuracy of deep neural nets, which act as black box systems. So interpretability is very important, and explainability is also important. When on a particular input instance, the system is taking a decision, it must tell us why it is taking that decision, based on which portion of this image the system says it is okay, it is having something. Some sort of bacterial pneumonia and so on. This I will not go through this work. This is one of our work which tries to manage the lesion detection from biased data. And this was published this year in the Icaa conference, which is one of the frontier conferences in medical imaging. Final slide. Miles to go before we sleep. Training data has to be inclusive. We do not connect language with culture, but they are inherently connected. In a multilingual country like ours, some phrase may be very humble in your native language, very offensive in my native language. So when there is a cross-lingual conversation, these cultural idioms have to somehow be adopted into your language model. Generative AI models should include detection and differentiation mechanisms as a condition for public release. All over the world, demand is coming. ChatGPT has released it. Be sure there is no software which can tell apart ChatGPT's text very accurately from human written text. Those who claim to humanize text are just doing business. Got it? And finally, this carbon emission aspect, the green AI comes into picture because all these models are very heavy. MedPalm 2, I showed you. For MedPalm 2, Google employed 2,286 A100 processors. Each processor costs 15 lakh INR. So the budget just for this MedPalm 2 was 500 crores, the annual budget of IIT Bombay. You get my point? And it gives rise to huge carbon emission. So where should we look? We should look back into our brains again. I will end up with the last 1 minute analysis. Have you heard of Fukuoka? Fukuoka, Japanese supercomputer. It was the world's best supercomputer till 2022, perhaps. It was performing how many flops? 442 floating point operations per second, consuming the power of sufficient electric power which can enlighten a big 3-story building for many days. And the thing that we are carrying between our shoulders, that means human brain, if you model it as a parallel distributed process, that it performs one exaflop calculation. What is 442 petaflop? 442 to 10 power 15, right? And one exaflop means how many? 10 power 18. So it performs 10 power 18 flops, consuming the power of a 10-watt power. Nobody knows what are the exact roles of the glia and astrocyte cells, what are the roles of the folds in our cerebellum, and so on. So we need to look back into neuroscience. And finally, our goal should be not to only aid the e-merchants who steal all our Facebook user data or YouTube user data, etc. Nothing is free. When Facebook or YouTube comes for free, you are the commodity actually. So we should not only help them, we should use AI to help people so that even the people from most marginalized communities can leave their heads being held high. That should be the futuristic goal of AI research. Thank you for this nice.
So yes, we are already there. So hurriedly we can take a couple of agendas if there is any.
Yes.
I have questions from your last slide. Say that these models, the very model needs huge computing power. So I have 2 questions. First of all, is how you are doing this type of jobs in your lab in Icaa, and number 2 is as far as our institute is concerned, how we can do this type of jobs in our small capabilities.
That's a very, very contextual question. Please have a seat. So first of all, pre-training is really huge. We don't have access to the foundation models under GPT-4 or Palm or maybe Meta AI, etc. Meta AI is a part of WhatsApp now. We don't have access to their foundation models. And they're huge, beyond our capability. But fine-tuning requires much less data and much less effort. So you should, and there are many, many applications which are constrained in terms of memory. Telemedicine network, why? So this Llama 8 billion model that I was just showing in a glimpse, you can train very easily with 1 GPU. Okay, maybe RTX 3090 is sufficient. But if you wish to train a VLM with image and text both, you need to have at least an A100, which will cost you 15 to 20 lakh rupees for the full installation. So what we do is we use the Hugging Face interface where the ecosystem of transformer models and so on. Sometimes use scan. We sometimes do simple fine-tuning. We sometimes do critical research to understand why this LLM is hallucinating, how to measure the hallucination, this sort of research. We are also helpless. We cannot create or do heavy changes in the foundation model of these LLMs because they are really beyond our capacity. And this is also a danger sign. After the introduction of LLM, the entire research in NLP has been destroyed, actually. Because everything is done by it. Now the SAM has come. computer vision domain will be destroyed. We can see that. Because there is a single model, the entire model is under the autocracy of a single company, and they similarly it's like OpenAI. They will control. This trend is dangerous, so we have to be cautious. And that's why there is a demand that all the foundation models be released over the cloud, free access be given to certain research groups in India. I don't know how much that government will facilitate those things, but for now I can tell you, fine-tuning and adapting an LLM for your specific purpose is easy and you can do it within your capability. That's how the startups are surviving. At least a GPU is. Kaggle or cloud is okay, but there are a lot of problems. They are also very limited. There are queues and jams and access problems. Money, they will also require huge amount of.
The training that is happening even for ChatGPT, stochastic means what I'm saying is if there are two ChatGPT is being built like training, maybe they are given the same data but in different order and different times. And in the training be same, I mean it's like
Training is always stochastic. Hallucination is basically caused by
what I was thinking while you were delivering the lecture, like we went to the same colleges and universities, went to the same department, being 3 years late than me, and you were working in the institute where I have been there for a long time. But that later outcome is different. Like you were I don't know. Voice is the second most cited researcher in India. Okay, but maybe it has changed. Maybe he's now top one because the top will builder is also changing. Like sometimes you get somebody and sometimes somebody else.
that is a different
but
thing.
so the ChatGPT can also have
It's a very nice question. In fact, if we both of us would have the same specialization, we would have read through the same books, same class, same supervisor. Then maybe you went into computer science, core computer science. I went into AI. This bifurcating is because our training sets are different. If the same internet-based training repositories are used because of the stochastic training, the answers will be different, especially for questions which are not extremely factual. You see, you both are trained in English.
There are so many students in the class. Maybe they started at the same level at the first year, but the outcomes are different. Because there are different things happening in one or someone's life.
Students are human.
But you see, the brain capacity after all is just a chain of neural network. And they are starting from almost the same place and having different outcomes.
They are not ranked up to the same epoch, the same number of epoches. But here, if the training happens up to the same number of epoches, only thing that will differ is if you ask who is the Prime Minister of India, they will answer the same thing. But if you ask them, write 5 sentences about the state of Indian democracy, they will write 2 different paragraphs. That can be very difficult.
Okay, I think we can take up this philosophy, Mother T. Basically, within these 50 minutes, I was thinking, we have gone through 1942 till date. And the whole coverage, basically nowadays that is the postgraduate 2 years program in various institutes abroad. So that we have taken in 50 minutes. So lots of issues will be there, but it's a bird's eye view. So thanks a lot to the speaker, Professor Shagatam Das, and I request all of you to give me the exam.
Thank you so much, sir, for your enriching talk. I'm sure our students have enjoyed it the most. Now, I would like to request Professor Dr. Sanjay Saha to felicitate Dr. Dash. We would like to express our gratitude to Professor Dr. Shaha for taking his time to chair the session. I would like to request Professor Dr. Dinabandhu Bhandari to come up on stage and please felicitate Dr. Shaha. Thank you, sirs. Now we will have a 10 minutes of coffee break. After the coffee break, we will start our technical session and the papers with PID 9, 81, 91, 24, 42, and 33 will be present. Among these papers, PID 24 is a short paper, and papers with PID 42 and 33 will be presented online. I would request all the presenters to remain ready with their presentations. Thank you.
बच्चों का बैग ले लिया क्लास करके एक क्लास छोड़ते हैं कंपल्सरी क्लास মেল ডক্টর মানে আরে ওটা ওটা মানে আমাদের সোসাইটি যেমন वॉलेंटियर में नहीं है कितने लोगों को लिया वॉलेंटियर कौन कौन
चार जो
नहीं पैसे असाइनमेंट जमा करना है
ऑलरेडी मैंने चाहते हैं
वो अच्छा ना पागल नहीं यार जानते थे कि बोल ये बहुत कोई वो मार्केट की जरूरत है फटाफट भी খালি গোটাটা দেখি আমরা এবার গোটা স্যার আসবে দাওয়া দিবেন না মানে এই তো প্রমাণ দিচ্ছে তুই হ্যালো আমি বললেন কাজ ভালো করে আজকে আজকে বুঝে আসবো আমি কলেজে বেরাবো একটু পরে কলেজে কলকাতা এইটা দেখার জন্য মানে আমার দেখতে পাচ্ছি